Let's talk about area or surface area of cylinders. So cylinders are a three-dimensional shape, while area is a two-dimensional measurement. So the way we're going to approach this is we're going to take this three-dimensional cylinder, break it up into its two-dimensional parts, what we'd call its net. So to break this cylinder up into its two-dimensional parts, we're going to take the top off, which is a circle. We're going to take the bottom off, which is a circle. And then we're going to slice the middle portion down the center there and unravel it. It's kind of like unraveling a toilet paper roll, right? If we unravel that, we've got a rectangle. There you go. So there are the three two-dimensional shapes that make up a cylinder. Circle at the top, circle at the bottom, and then that middle portion unravels into a rectangle. Now, to find the surface area of the cylinder is just the simple practice of finding the surface area of these two-dimensional shapes. One last important point is this length of the rectangle. Remember, that was wrapped around that circle. So that length of the circle, unravel the circumference of the circle, and it matches the length of that rectangle, because that's what is wrapped around. So the length of a rectangle is equal to the circumference of those circles. So that's the idea behind finding surface area of the three-dimensional shape of a cylinder. Let's apply it. Let's do an example. Let's go ahead and set up our general equation before we go any further, and then we'll actually put some numbers to this. But here's our cylinder, and then here's its net, unraveled into its two-dimensional parts. So we've got our height, our radius, and then this length here, remember, is equal to the circumference, which is equal to 2 pi r. All right. So let's talk about the surface area of a cylinder. So we have the area of the circle, pi r squared, but then there's two of those. So there's one up top and a second down below. So we actually have two of those. And then added on to that is that rectangle in the middle, which is our height times our length. Now our length we said is equal to circumference, so we have 2 pi r squared plus our height times, and that length is our circumference, or c, or 2 pi r. So there's our general equation. I might put that h at the end just to make it look a little cleaner with the 2's coming first. So 2 pi r squared plus 2 pi RH. There we go. There's a generalized formula for area of our cylinder. Like I said, let's put some numbers to this. Let's say we had a height of 14 feet and a radius of 8 feet. So that's the same over here, just our unraveled pieces. So R is 8 feet on this circle as well. Our H is 14 feet. And our length, we're not sure yet. We'll have to find the circumference doing that. So let's find the total area of this cylinder that's 14 feet high with a radius of 8 feet. So we have two circles, and the area of those circles is pi r, in our case is 8 feet squared, plus the area of that rectangle, which is the circumference, or 2 pi r, 8 feet for our radius in our case, times the height, which is 14 feet. All right, let's clean this up a little bit. So 8 squared is 64. 64 times 2, 128 times that pi, plus, let's see, 2 times 8, 16. 16 times 14, that's 224 pi. And let's go ahead and combine those. 128 plus 224. 352 pi. And these are feet squared, because we're area, second degree measurement. So we're squared there. There's our answer. Now we can do an approximate decimal answer as well. Go ahead and go to my calculator here. 352 times pi gives us about 1,105.8 square feet. So an approximate and an exact answer. There you have it. Surface area of cylinders.